test is tomorrow. Test needs to be done tomorrow. For you guys, again, like we were just saying, you'll have time in class tomorrow to take it. At Homer's, you'll have to get it done sometime between the hours of 7 a.m. when it opens and 11:59 p.m. when it closes. So you got, it's 10 questions. It is part 1 of the test. Okay? Part 2 of the test will come next week, Tuesday, with the launcher lab. Okay? So part 1 is the online, it's learning portion. Part 2 will be next week. Okay? The review assignment at the tail end of your brown packet, the last 3 pages of your brown packet, that is also due. And that's take a picture, send it in, or show me at some point, like tomorrow you could show me in class or that kind of a deal. Okay? So, all right, we didn't want to but we didn't want to have an entire hour to take those 10 questions. So we're actually jumping ahead today to section 6.4, okay, which is our next section. And it's all about polar coordinates. My plan is to go up until about 11:30, 11:35 today, and then open the floor for questions at the end about the 6.3 test that you're going to take tomorrow, if you have any of those hanging out there. Okay? So, first off, let's take a step back in time, and let's talk about ordered pairs. Okay? Points, if you will, okay? Before we get to polar. Okay? So this is what is called a Cartesian coordinate system. It's the XY plane, you go, and I call it the Batman plane, if you will. Okay? Because Batman and Robin are sitting here at the Bat Cave. And they jump in the Batmobile, and they've got to get to the Joker. Okay? Well, they can't just drive there in the Batmobile, so they've got to first drive down this road, and then they've got to drive down that road to get to the Joker. Okay? And that puts it at the point of the Joker is like X comma Y. Okay? You have to go a horizontal distance and a vertical distance, and that locks in that point. Okay? Okay? So that is what René Descartes, a famous French mathematician, came up with for a system of spatial type things. It works. Okay? Batman and Robin, they're cool. But what today we're going to talk about is we're going to be like Superman. Okay? So Superman is sitting here at his Fortress of Solitude. Okay? And we're going to call the Fortress of Solitude, we're going to call that the pole. Okay? It's your starting point. I forget, did Superman have a signal? Like, I know there was the bat signal for Batman. You had a watch? Okay. Yeah. Right, well, so the watch goes off then, right? And Lex Luthor, oops, got the brakes. And Lex Luthor is there. How does Superman get there? He flies right there, right? He takes a direct flight right to Lex Luthor. And here he comes to save the day. So Superman just flies right to him. Okay? And that's what Polar is. Polar is a brand new system of points. And we can go to any point, just like we could in a Cartesian coordinate system. Okay? We just have to know two things. Okay? The first thing that we have to know is we have to know, wrong color. We have to know how far Lex Luthor is away from the Fortress of Solitude. And we call that R. So R is the distance that your object is, or the distance from the pole. The other thing that we have to know is we're going to have to know this angle. We're going to have to know theta. Because that's going to be the direction that Superman flies in. Okay? And so theta is the angle from the polar axis. And this down here, this is your polar axis. It's the 0-degree ray. Okay? In a Cartesian coordinate system, you've got an x-axis and you've got a y-axis. In a polar coordinate system, you just have the polar axis. Just the one. Okay? Now, let's talk a little bit about theta, because we've had different directions going on so far. Theta is, it can be positive or negative. So theta can be positive or negative. If we go positive angle, we would go counterclockwise. Negative angles, we would go clockwise. Okay? And it always starts out to the right. Okay? 0 degrees is always to the right. Does that sound like something? Sounds like the unit circle. Yep, exactly. This is all. Oops. Oh, bad. Oops. Erase bad. unit circle angles the whole way through polars. Okay? So it's not directions. It's not bearings. It's not north 78 degrees east, okay? Or east, 32 degrees north or whatever it is. It's all straight up unit circle. Okay? So we're back hardcore onto the unit circle. Okay? So if you have those two things, if you have r, the distance you are from the pole, and you have a direction angle off of the polar axes, you can make it to Lex Luthor. And these points are going to be of the form r, comma, theta. Okay? So polar points are r, comma, theta. Now, if your theta is in radians, that's fine. If your theta is in degrees, that's fine. They mean the exact same thing. Okay? So if I told you to graph on a Cartesian coordinate system, so on an XY plane, if I told you to graph the point 3, 4, what would you do? You would go right 3 and up 4, right? And you'd put a dot. And that would be the point. Okay? So let's try graphing now on a polar graph. If you'll notice, our polar graphs are different because they're circular. Because if we had a string, and I don't have a string with me right now, but if I had a string and we hung it out, and if I stayed put, everywhere at that string length around me would be the same distance, the radius of the circle. Okay? So what this is saying is that we are 2 units away from the pole. And the angle is saying that we are pi over 4 or 45 degrees off the polar axis. Okay? So this is 0 degrees. Straight out to the right, 0 degrees. Okay? 90 degrees then, because we're going in the positive direction. So we go counterclockwise, 90 degrees, straight up. So 45 degrees would be halfway. Side note, on these particular polar graphs, they're by 15s. They're broken up by 15. Okay? So we go there. So we start at the pole, and I need to go 2 units away. So that's 2 rings, 1 and 2. So right here is the point 2, comma, pi over 4, or 2, comma, 45 degrees. Because I'm 2 units away. With me? Questions, comments, concerns, clarifications? Okay? Try number 2, okay? Because then we'll talk about number 3, because number 3 is a little bit different. Try number 2. So again, this would be 0. This would be pi over 2 up here, or 90 degrees. This would be pi over here, or 180 degrees, which puts 5 pi over 6 as that one, okay? Or 150 degrees. And then I need to go 3 units out, 1, 2, and 3. Put a big old dot right there, and there is the point 3, comma 5 pi over 6, or 3, comma 150 degrees. Okay? Now, with this one, with this other one, now we've got a negative. Oops, first off, tap brakes. Let me put this as 4, negative 3, comma 150 degrees. Okay? So this one, when r is negative, so if r is positive, we go towards that angle, right? Right? Okay? So what happens if r is negative? We're going to go away on that same line, but we're going to go backwards. Okay? So a negative r means you are going to go through the pole in the opposite direction. So 5 pi over 6 was this one right here. So rather than go towards 5 pi over 6, we're going to go 3 in the opposite direction. 1, 2, and 3. Oops, I put it in the wrong color. 1, 2, and 3 right there. Okay? So instead of going on the ray towards 5 pi over 6, we're going to go backwards on the line through the pole. Okay? Love it. Now, the next one says, plot the point and find 3 other ways to name the point. I will tell you that there are 4 possible ways to name each point. Okay? So when we're in the Cartesian XY coordinate system, there's only one way to name every single point. Okay? 3, 4 is 3, 4 and only 3, 4 in the XY plane. Okay? In polars, here's the downfall with polars. In polars, we can name this point, this exact same point, we could name it with a positive r value and a positive theta value. We could name it with a positive r value and a negative theta value. We could name it with a negative r value and a positive theta value. And we can name it with a negative r value and a negative theta value. And all end up in the exact same point, or the exact same place. Okay? So there's 4 different names, 4 different addresses, if you will, for every single point. Okay? So first off, let's find what this point actually is. Or where, I should say, this point actually is. Okay? So we've got a negative theta value. So that's going to be 0. This is going to be negative pi over 2 down there then. Okay? Negative angles coming into play again. We go the opposite direction. Okay? Which would mean then that this would be negative pi over 3. Oops. This one would be negative pi. You'll see why in a minute. Because I went 6 on this one. I don't know why we went 6 on this one, because there's only 5 rings on it. So that means then that we're going to go 1, 2, 3, 4, 5, and 6. So there is our point. Okay. Now, could we change the scaling? Yeah, we could have made each ring be 2. Just like we could change the scaling on a Cartesian XY graph, we can change the scaling on a polar graph too. Okay. We just got to, label it somehow. Okay. So there it is. Now, how I like to do it, and by no means is this the only way, but I like to figure out what angles I'm dealing with then. Okay? So I am dealing with here this ray, or that line, if you will. Okay? So that's negative pi over 3, but that would also be positive 5 pi over 3, correct? Because if I go on I'll go to the window. You're fine. You're fine. So if I'm here at negative pi over 3, that's also, if I go the positive way around, that's also 5 pi over 3. See how that works out? Okay. On the other end of that line, at a positive direction, I'm at 2 pi over 3. From here. Because, so, positive direction, I would go up counterclockwise. Yeah. Negative direction, I go this way. So I got to go down here to negative pi over 3. It's negative 60 degrees, if you will. Okay.
Oh, so you like
Yep. Yep. All right. 2 pi over 3 is also negative 4 pi over 3. So those are my 4 angle measures. Okay? 2 positives and 2 negatives. Okay? So if I'm going on my original one, I would have 6 negative pi over 3. I would also have positive 6 and positive 5 pi over 3. If I'm going on the other side, so the other, put a break there, okay? So this would be positive r's, this would be negative r's. Okay? So then the other two would have negative 6 and positive 2 pi over 3, and it would have negative 6 at negative 4 pi over 3. Graph them. Find me the other 3 names for those exact same points. So 210 degrees is down there, right? So the alternatives for 210 would be negative 150 there, and over here it would be 30 degrees and negative 330 degrees. Agreed? So the original point would be 1 and 2 would be right there. That's my original point. The negative 2 comma 210 degrees is right there. The alternatives would be negative 2 comma negative 150 degrees, positive 2 and 30 degrees, positive 2 and negative 330 degrees. Yes?
If it's degrees, you have to then do the alternatives into degrees. Can you do like
Up to you.
okay.
Yep. Usually we say if it's, whatever the original one is, then do them in the other ones. Yeah.
But I accidentally do that.
That's fine. Mm-hmm. Especially like when you get to radians, because it's easier to see it in degrees. Because these two numbers, the absolute value of those two angles should always be 360. Okay. So 3 pi over 6. Well, pi over 6 is that one right there. 3 would be 1, 2, and 3. So right there would be the original point. This would also be negative, not negative 5. That only gets me to pi. This would also be negative 11 pi over 6. And this one down here would be 7 pi over 6 and negative 5 pi over 6. So the three alternate ways would be positive 3, comma negative 11 pi over 6, negative 3, 7 pi over 6, and negative 3, negative 5 pi. Because you got to give the other 3. You got to give the other 3. So you got to have a positive and a positive and a negative and a positive and a negative.
So you have.
What do you mean?
Like on the actual. Yeah. How do I know?
So these two are going to be the positive directions because that's where the point is. Okay. These two are going to be the negative R values because it's the backwards way.
So it was negative 3, so the same way. Negative 3 and positive.
So if we had negative 3 pi over 6, then it would be right here. And then these two would be the positive R values, and these two would be the negative R values.
So like those numbers never change.
These angles never change. It'd be negative 3 comma 7 pi over 6, negative 3 comma negative 5 pi over 6. Or excuse me, I misspoke. Positive 3, 7 pi over 6. If my original was that. Okay. Then again, this would be positive 3, this one, positive 3, that one, negative 3, negative 3. Okay? Okay? Yes, ma'am.
Do we have to list all 4 points when we're plotting? And are you just
If it asks for it. Yep, if it asks for it. Okay? Alright? That's where I wanted to get to today. I'm a little bit over the time that I wanted to go, but that's alright.